Hi, everybody. How are you guys doing? Hopefully well. So I have several things that I want to talk to you about and walk through with you. Uh, One is your data analysis assignment. I know that a few of you have emailed me and asked me some questions about it. There's also a few of you that have finished, so that's great. So what I want to do today, though, is to kind of walk through that assignment. I know that there's, maybe questions about what it's asking you to do, and I want to go through that procedure with you. So this is the actual assignment. I did kind of move some things around just to make sure, because I don't think the way the assignment was written in LoudCloud is user-friendly. I think it was a little bit out of order. So I kind of altered that a bit. And so as you know, you're given some test scores, okay? And then you're asked to identify the mean, median, mode, range, variance, and standard deviation for the example. So, so the first thing that I wrote, wanted to talk about was the actual definitions of these things. And then the procedure as far as what the assignment was expecting you to include, and a little bit more in this order. So, so let's go back here just a little bit. Okay, so for the mean, these should not be new to you in any way. In fact, none of this should really be new. But the mean, median, and mode is something that you had back in junior high, and maybe even before that. So it doesn't really warrant a lot of discussion, but anything can warrant review, right? So the mean actually is a measure of central tendency. It's the most commonly used measure of central tendency. And given you have a set of scores that are provided to you, you need to find the mean. All you're going to do is add up the scores and divide by n. So the median is the literal middle score in the distribution. So you'll order the scores from lowest to highest, find the middle score, and then if there's an even number, you're going to take the average of the two middle scores. I'm going to show you, some examples of these in a minute. The mode is the most frequently occurring score. Moving on to measures of variability. The range, you would subtract the lowest score from the highest score, so it gives you just an idea of how spread apart the data are. And then the variance and standard deviation, we'll look at a video in a minute that show you how to calculate those. And so included also in the video is sort of how you need to follow the procedure in order to be successful with this assignment. So, so you're going to do these things. You're going to state your results for the mean, median, and mode, and standard deviation and variance. So that'll be the first thing you do. And again, you'll be using these data up here. You'll also be conducting a one sample t-test and interpret the results. And I am going to use, on the video, I'm going to run an example of a one sample t-test hypothesis test, which will be included in this actual assignment. You'll then write a 500 to 700 word summary and analysis discussing the result of your calculations. Okay. And I sort of expanded on this just to clarify what the question was. In what situations would this information be useful? So you have these test scores, and you're going to get the mean, the standard deviation, and be able to talk about your results of the hypothesis test. But for example, why would knowing this information be important given a set of test scores? You want to write about the mean, the standard deviation, and the usefulness of conducting a t-test. All right, just in the context of the calculations, right? This assignment is, you need to prepare this assignment according to APA style guide located in the Student Success Center. An abstract is not required, and I've added this, or actually subtracted this. Citations are not required. If you want to use a citation, you may. I'll give you maybe 2 or 3 extra credit points if you do that, or if you've already done that. If you have done that, or you would like to have a few extra credit points and you use a citation, can you, at the top of your document that you turn in, can you write at the very top, citation included, just so I don't forget to give you the points. This assignment does use a rubric, so you need to review the rubric before beginning the assignment or as you're doing the assignment to become familiar with the expectations for successful completion. I don't know how many times students do their project and it's clear that they did not use the rubric because there's whole sections that are missing, and sometimes those sections are worth like 20% of the grade. So to almost ensure a good grade on this, please use the attached rubric. It's in Lopes, right? And I may have attached it to the announcement as well. Make sure that you look through that. If you've already completed your work, you can go back and make sure that you have everything included. Yeah, so I have moved the date for this. Once again, I gave you and moved it to the 20th, so you have a few more extra days to complete it. And I put that on the calendar as well, so that should be moved at this point. So those are kind of the things that I want to go through, and I have a PowerPoint which I'll also attach, but I'm going to go ahead and pull that up so we can all see that. Okay, let's see. No, hold on a second. Okay, so what I just walked through was your assignment, and this is what I'm going to actually kind of walk through again. It's more of a demonstration of what I just talked about. So if you want to have that document in front of you, you can kind of follow what I am discussing here. Okay, so let me pull it next. Okay, so this is about the data analysis assignment. Again, it's going to be due on the 20th now. So here we go. Okay, so the purpose of this little demonstration or this presentation is to provide clarification and expectations about the data analysis assignment. Your data assignment is due on the 20th, so I actually need to change that, but it's due on the 20th. If you've already done it and submitted it, great. But you can also, go back and just make sure all your boxes are checked. So I'm going to break it down today. You might want to go back and make sure that you have everything from the rubric and every expectation that we talk about today, so you can make adjustments if you need to. Okay. So the mean, median, and mode. Let's look at an example. So let's say that I have hypothetical data that's been provided. So these are the data that's based on a quiz scores for one particular class. Okay, so for my mean, I have the sum of the scores, of the X scores, divided by N. So I've just added all of these up, okay? And so I get 180 divided by 10, which is the number of scores. And so my mean is 18. For my median, Okay, it's a little bit off. So for my median, it's the literal score, middle score in a distribution. So there's really no math to it. So the way you find it is that you add the order of the scores from lowest to highest, and then you find the middle score. If there's an even number of scores, take the average of the two middle scores. So in this case, the two middle, there's an average number, which is 10. So the middle two scores are 16 and 18. So we have our median as 17. And like I said, there's supposed to be a little more, looks like the formatting is just a little bit off. Okay, so for the mode, this is the most frequently occurring score. So if you look, you can see that 15 occurs twice, and there's no other scores that occur twice or more than twice, so that means 15 is your mode. Okay, so now we're going to move to the range, variance, and standard deviation. So here, let's see, oops. So let's just kind of forget this. These are not the data. We're going to use the data that we had used before. So let's ignore that. So the range is just subtracting the lowest score from the highest score and gives us an idea of the spread of the data. So sorry about this. So 27, the highest score, minus 10 would be 17. So 17 is our range, okay? And then our sample standard deviation formula. So we're going to use a sample standard deviation. There's also a population standard deviation. We're going to use the sample just because we are calculating a t-statistic, and a t-statistic is based on an unknown variance. So we're going to have to estimate what that standard deviation is using the sample. So this is a very messy drawing of what the sample standard deviation formula looks like. And so we're going to go ahead and I'm just going to show you how we create that table and do it by hand. So we have all of our scores, and you don't need to put all of them in order, but you can. So you're going to have one column. You can end up with several columns here in a table. But if you have this quiz scores, I'm going to list them vertically. And then for my the next step is to calculate the mean. So we already know how to calculate the mean. All right, so and we already have the mean, so the mean is 18. So we have 18 is the mean, so we just take 10 minus 18, 13 minus 18, 15 minus 18, and the answers to those will be our deviation scores. Okay, so these are going to be how far away the score is from the mean. Okay, 10 is 8 scores below the mean, 13 is 5 scores below the mean, 15 is 3 scores below the mean. Okay, and then the last step, or one of the last steps, is to create your fourth column, which is called the sum of squares column. So all of these should equal to 0, and if we have sum of these equal to 0, well, there's not much we can do with 0, right? There's not a lot of there's nothing we can do with 0, so we want to have an actual number that is our standard deviation. So in order to do that, we're going to square these scores. Okay, so we're just going to square the deviation score. So 8 squared is 64, 5 squared is 25, 3 squared is 9, and so on. So now we have our squared scores. If we add all those up, we have 258. And so 258 actually becomes what we call our sum of squares. Okay, so I'm going to show you more about how we use this in our one sample t hypothesis test. So for the first part of your assignment, you'll be using the data that you're given, and then you'll just kind of follow this example to calculate those values. Okay, so so I've also well, anyway, let me go back. So your assignment asks you to conduct a one sample t-test using the data they give you. I realize that it's probably been a while since stats, and so I want to just help walk you through how to conduct a one sample t-test. Now, in one of the videos I posted last week was a two sample t-test. And, you know, I kind of walked through some examples there. So this is actually kind of a step back. This is only using one sample. And so this particular example that I'm doing will be very much like the one on your assignment. Obviously, you'll be using different values, right? Okay, so the scenario. A researcher is testing the effect of a new cold and flu medication on mental alertness. A sample of 9 college students is obtained, then each student is given the normal dose of the medicine. 30 minutes later, each student's performance is measured on a video game that requires careful attention and quick decision-making. The sum of squares for these data is 72, and our alpha level is going to be set at 0.05. And our alpha level is the level of significance, or alpha level is actually going to be what we use to determine if we're going to reject the null hypothesis or not. So assuming the scores for a regular population average 10, does the new medication have an effect on mental alertness? So one thing also that I'd like you to keep in mind is that this is just a little example and a hypothetical example of a research study. If you're struggling still to come up with methodologies, this is a good example of methodology. So your question, your participants, what you're gonna do, your procedure, and you know, so this is a very, very short example of a research study, but if you're still struggling trying to come up with the right methodologies, maybe this could be an example of how you might want to answer your question. So we're going to assume the scores have an average of 10, for a regular population average of 10, and I want to know if the new medication has an effect on mental alertness. Okay, so let me actually want to, okay, so what I want to do is switch over now. I have a sheet that I also included on the announcement. So I'm gonna go ahead and pull that up. And I'm gonna pause my share so I can pull that up so we can look at that together. All right, just give me a moment. Okay, so here is the example. So like I said, this example is very similar to the one that you have for your assignment. I think the difference is that we'll have already calculated the mean. You will have you'll be given any data that you need, so you're not actually going to have to do anything extra that we did. So if you just follow the steps that we went through on the PowerPoint, you should be fine. Okay, so a researcher would like to evaluate the effect of a new reading program for second grade students. Over the past 5 years, a standardized test given at the end of the second grade has produced a mean score of 45. A sample of 25 students is placed in the new program, and at the end of the school year, they obtain a mean score 51 with a sum of squares of 9,600. So you guys already can calculate that. Okay, so you can calculate all of this already. Okay, so based on these data, can the researcher conclude that the new program has a significant effect on reading scores? So I've just included this little bit about a two-tailed test. So this is a two-tailed test versus a one-tailed test because the term effect is non-directional. So when I say I want to see a change or I want to see the program affects reading scores, then it doesn't indicate a direction. So for that reason, I'm going to use a two-tailed test. Okay, so the first step is to state the hypotheses. So this is how the null hypothesis is stated. This is how the alternative hypothesis is stated. And so what I want to know is if my mean after treatment is not equal to 45. That's actually what I hope, because 45 is the average population score on reading it overall. But I want to see if my group actually scores differently. I'm hoping they do, hoping they're going to improve actually, right? The null hypothesis is there's no change. So I don't want that to happen. I don't want my final mean to be 45, or else that means there's no change, and probably the null hypothesis is true. So my second step is to set the critical region. So there's a critical region is set by the alpha, and I have down here, the alpha level will always be set at 0.05. So what that means is that I'm going to set my my critical region, okay, to be 5% total of the distribution. So if I fall into a region that I've determined that is 5% of the distribution, then my mean falls into those critical regions, then I can reject the null hypothesis. So I've just kind of set a boundary. So on this side, it's, retain the null hypothesis. On this side, it's reject the null hypothesis. So this involves looking at my t-table. So I think, okay, here we go. No, let's see. Okay. Okay. All right, so this is an example of the t-table. Now, if you look in your, I actually think I included a screenshot of this, but I can also include a packet of a whole bunch of statistics tables, which you won't need except for this one. So this is called the t-distribution table. I think it would be in the packet I send. It would be like the 5th page, and it's just one page. Okay, so let's jump back to new share. second. Okay. All right, so I guess I'm back. So I have, for step 2, we're going to determine what the critical region is. So I'm working with a normal distribution. And so first of all, I need to find the degrees of freedom. So if I go up here, I know that I have 25 students. Now, degrees of freedom is n minus 1. So 25 minus 1 is 24. So I'm then going to use the t-table to find my critical value. And apologize for all of the back and forth here. Okay, so if this is what my t-table looks like. So if my degrees of freedom is 24, okay, so 24. And so I have set my alpha at 0.05, and this is a two-tailed test. So this is where I need to look. So at 0.05, the two-tailed test, I'm going to scroll all the way down here, and I am going to find that my critical T is 2.064. All right, so then I'm going to just go back here. Sorry about all this back and forth. All right. Okay, so my critical value is plus or minus 2.063. All right, so my mean that I get, my t-statistic that corresponds with my mean, my data, has to fall into above 2.063 or below 2.063. So here are my calculations. So we are using a sample to calculate our standard deviation. So this is stuff kind of that you've already done, or that I showed you a little bit ago. You'll just have different numbers to plug in. So we didn't look exactly at sample variance. Sample variance is, all that is actually is standard deviation, square root of the standard the standard deviation squared. So the actual formula is sum of squares over the degrees of freedom. All right, so in our case, 9,600 over 24, and then our we're going to get 400. You take the square root of that, and we'll get 20. So for your assignment, whatever standard deviation you get, you can just square that, and that'll be the variance. I know they're asking for the variance as well. So here's sort of the tricky part we have to remember. So we're using a sample to calculate the what we call the estimated standard error, which is going to go in the denominator of our formula. So what that looks like is we're taking standard deviation of the sample divided by the square root of n. The standard deviation of the sample is 20 divided by square root of 25, right, which was 5, and that's going to give us an estimated standard error of 4. Now, 4 is not the t-statistic. 4 is the denominator, the error term of the t-statistic. So we're going to take m minus, this is the t-statistic formula, m minus mu divided by the estimated standard error, And so 51 minus 45, where did I get that information? We have to go all the way up here. So our sample mean was 51 and our population mean was 45. So we're gonna go back and just show you. So we'll go back to one sample, I'm sorry, to our t-statistic. We know now the difference between the means, and we, of course, know the formula, the estimated standard error. So we can just subtract those. Okay, so 6 divided by 4 would be a positive 1.500, and 1.500 is going to be not going to be above 2.063. So it's going to be somewhere in here. So if it's in this area, then we're going to retain the null hypothesis, which means that there are no significances from the results of our reading program to like the average results of the reading program of all students. Okay, so we're going to retain the null hypothesis. Now, I am actually not going to have you do the effect sizes. This is actually, you know, if we were doing an actual stats class, I would want you to do these and interpret these. But let's just jump down to the decision part. So like I said, I retain the null hypothesis. Now this is going to be the answer, and I don't remember what number it is, but one of the questions is interpret your findings. This is the one where you have to write like kind of a short essay, but this is part of doing that. So you can retain the null. We found out that the reading significant effect on the reading scores, and this is out. So there's a statistical sentence that peer review like to see because it just gives you know, validates what you said you found, right? But here's the values that sort of prove that. So we're going to put our t-statistic equals, in this case, positive 1.500, and in parentheses here, we're going to put the degrees of freedom. Okay. Then our p-value, which is going to be the same as our alpha, is going to be 0.05, but depending if we retained or rejected the null, this directional signal changes. So if we retain the null, which is what we did now, we're going to write p was greater than 0.05. And what that means is that we actually had a probability that was greater than 5% chance of committing a type 1 error, which means being wrong. Okay. And you won't need to write to do the effect sizes, like I said. So what's really important is the t-statistic and the p-value. Now, if you reject the null hypothesis, you will your p-value will still be 0.05, but the direction will change so that it says p is less than 0.05, which in other words means that we had a less than 5% chance of committing a type 1 error, okay? And then a type 1 error is saying that we rejected the null hypothesis or that we did find a treatment effect when there really wasn't. So that's essentially what that description is. So this is this would be exactly a part of that question on your assignment that asks about how you would interpret the decision. Hey, this is definitely part of that. So, so yeah. So basically, I hope I didn't go too fast, but you can always, you know, pause and rewind. So essentially, that is sort of a breakdown of what is expected in your data analysis project. And if you have any questions, you can email me. And then I'm going to come back in a minute. I'm going to come back and post another something to talk about your quiz 6 and 7. I'm gonna collapse 6 and 7 together. Okay, so I think that's it for now. I'm going to go ahead and yeah, I'll record this and then I will post it as soon as possible to our announcements. All right, thanks. Have a good day.